So in this question here, I've got a point P touching a circle for which the formula is x squared plus y squared equals 16. And the coordinates of P is 2 root 3. Now our goal is to find the equation of the tangent to the circle at point P. So that is this line here. So how are we going to do that? Well, first of all, we know our x coordinates at this point here is 2 and 2 root 3. So point P is at 2, 2 root 3. So if we can find the formula for this straight line, we can then find the negative reciprocal to find the gradient of this line P. So let's find the gradient of this line here. Now the gradient is the change in y divided by the change in x. So if we have a formula y equals mx plus c, our m is change in y divided by change in x. Okay. Now if our x value is 2 here, if we go from the origin, the change in x is 2. So therefore m equals something over 2. Now the change in y, the y coordinate is 2 root 3. So this point here is 2 root 3. So therefore the change in y is 2 root 3. Okay, so now we know our gradient is going to be root 3, just by cancelling that out. So m equals root 3. Now we know that c is going to be 0 because that's where it touches the origin. So we could write this as y equals root 3x. That could be our equation for that line. Now we only really need the gradient to find the gradient and the of the y-axis for this point P and the tangent there. So let's find the negative reciprocal. So the negative reciprocal of m, so negative 1 over m. So what we want to do for that, let's call this our new gradient, which we'll call m2. So negative 1 over m, so this is our first m. So m2 equals minus 1 over root 3. So that's our gradient of this tangent line. So now what we want is to find y equals m2x plus c. Okay, now we've got some coordinates already on this line. We've got x is 2 and y equals 2 root 3. So we can plug them into this and find our value for c. So hopefully we'll get a value for c which is greater than 2 root 3, because we know it's going to touch the line here on the y-axis above our coordinate here. So let's see what happens. So we've got 2 root 3 equals m2, which is minus 1 over root 3, and then times our x, which is 2, and then that's plus c. Okay, let's just keep these calculations separate on this one here. Okay, right, let's see if we can get c on its own. So the times 2 we can put into this one here. So we've got 2 root 3 equals minus 2 over root 3 plus c. Okay, well, add 2 over root 3 to both sides. So now we've got 2 root 3 plus 2 over root 3 equals c. Okay, now let's multiply everything by root 3 to get this root 3 off the bottom. So 2 root 3 times root 3. Let's just put a times root 3 here just so we can see what we're doing. 2 root 3 times root 3 is going to be 2 times 3, which is then going to be 6. Multiply this by root 3, we'll be left with just the 2. And then that equals c times root 3. Okay, well, divide both sides by root 3. We'll get c on its own. So they will cancel out. So now we've got c equals 8 over root 3. So c equals 8 over root 3. So that's the first bit of information we've got there on our circle, on our tangent line. Okay, so let's write that up. So y equals minus x over root 3. That's our gradient. And then we add 8 over root 3. Okay, right, let's get this equation into something that's a bit more digestible. So y equals minus x over root 3 plus 8 root 3. Let's multiply everything by root 3. So times by root 3. And let's keep these calculations separate to what we have here. So times all this by root 3. We've got root 3y equals minus x plus 8. So that's what we got there so far. Now let's bring the x over this side. And then we've got x plus root 3y equals 8. And that could be for our tangent line, or our equation for our tangent line. So that is where it's a good place to stop.